Look at us. Look at our tan.
I know.
Did it? It feels like it got dark in here.
Yeah. Yeah, just like a little.
Hi.
Hello.
Hello, Logan. You guys have a nice week?
Yes.
What'd you do?
We both went to Destin, Florida, and with a few of our friends, and we had we rented out a house on the beach almost.
Yeah.
Nice.
It was a few hundred feet from the beach.
Uh-huh. Was it warm enough to swim? Not really.
Not comfortably.
Yeah.
Uh-huh. But it was nice. It was warmer than it's been where you are.
Yeah. Actually, right now it's really nice. It's in it's like 78, 79.
Yeah.
Wow.
Like
Okay. So the snow's over.
that.
Well, good. How much time did you spend there? A whole week?
A week, yeah.
Yeah.
We only got like a few days of the beach because it became like overcast and foggy and misty.
Yeah.
But it was still nice.
Good. Good. Nice.
How was
How
your
many of
week?
you were there?
Oh, 13?
Yeah.
Wow. Wow.
Yeah.
Nice. That's good. So before Walter comes, let me ask you something. After this week, Walter's going to China for 2 weeks, and so I asked about, he doesn't want to get behind, and the whole class. So my first thought was to not hold class for 2 weeks after this week, but then assign a week's worth of homework. So in other words, on the 20th, I would give you the equivalent of 3 assignments. But I could hold class the second week just for questions. Maybe, so Walter wouldn't be there, but maybe a good idea. So that would be the week of the 30th, March 30th.
Okay.
So what do you guys think?
That'd be nice. 'Cause,
Yeah.
Yeah.
Yeah, okay. I'll do that. Okay. So after this week, there won't be class the following week, but then there will the week after that. And I'll just answer questions on the homework and
So the 23rd or the week of the 23rd, we won't have class.
that's right.
Okay.
Okay. I mean, normally in MSON, we take spring break off. So hold on just a sec. It's my wife. She's going away on a retreat. Yeah, soon for a week. Yes. So the standard is during these. We try to coordinate with the students' vacations, and so you had yours, and then Walter's having his. So normally we take two of the 3 weeks off of class. But Miss Sobe said I could adjust it, basically. So
Okay.
so we're going to adjust it that way. That's right. So you won't have class. But I'll say again, I'm available. If you have questions, I'm supposed to have office hours, and just say, I want a session or whatever, and you got it. I'm here. Okay. All right. So what time is it? It is 9. So Walter should be on board pretty soon. Let's see, what else? So I'm going to start. I don't know. Right. And then the other thing that I wanted to say before we start is, in the beginning of the course, I just gave full credit for homework and class participation sort of as a matter of course if you were here and you turned in something. But some of the work has not been up to snuff. So and doesn't seem to always indicate enough effort. That's not true for everybody, but so full credit means that it's going to be a little harder than it was before. I want to see some effort, and if you have a question, then ask. Okay, so those, and also it will be important not to leave the homework given Friday, since it'll be so large, to the last minute. But that won't be a problem because we'll have class and you can ask questions. Okay, here's Walter.
Hi.
Hi, Walter.
Hi, Mr. Lewis.
How are you? How was your week? How was your last week?
Oh, it was pretty good. I liked it.
Good. So this week you got to get ready for your trip. So you're going about both weeks?
Yeah, I'm gone both weeks.
Right. So I just talked to Ryan and Logan, and we're not going to have class the first week you're gone, and the second week I'm just going to have a class for questions. So you don't have to attend, but Ryan and Logan will be able to ask questions. And of course, if you get it, if you have anything, you can send me an email or whatever. And I'm going to give 1 week's worth of homework. So this Friday, the assignment is going to be 3 times as long for those 2 weeks. Okay?
Okay.
Because we can't take 3 weeks off. That's too much. Where are you going? What cities?
I'm just visiting grandparents.
Uh-huh.
It's near Shanghai.
Uh-huh. Okay. Do you speak Chinese at home, or Mandarin, or what do you speak? Or Cantonese?
I'm like semi-fluent.
Semi-fluent. Okay, so that's good, and you'll get it more up to speed with your grandparents.
Yeah.
So that'll be good. Okay. All right. So today, first of all, you're going to need this for your homework. I'm going to hold this up. Were you able to make this, everybody?
Yeah, I think.
You think?
What does it look like on the back?
It looks like this.
I can't see it.
Okay. Right. Here, sorry. I gotta watch the camera. Right.
That's the front.
That's the front. That's the back.
Okay.
So C is in the same place. See, I'm holding on C here, and I'm turning it around, and this is C. It's still C.
Is that like fixed onto the cardboard?
Yes. What I did was I cut the 2 triangles out, and I pasted one on one side of the cardboard and pasted one on the other side of the cardboard.
Okay.
Okay. And then you have this, which is the bottom of that sheet. And the idea is to, so this is a little smaller. There we go. Right, so it fits on top, and then as you move it, there's different correspondences. Position 1, this is the home position, with A on top and B on the left and C on the right. That's the home position, but then as you move it, you keep track. And that's what Smooth Moves 1 is, the sheet that has you work with this. And that'll be part of the homework. Okay? Ryan, Logan, you clear on that?
Yeah.
Okay, so we got that. Then, so Walter said he forgot how to do this. So I'll remind you. I like to make one face the same color if possible, but that's just a little aesthetic thing I like. But this is this is the tetrahedron, and what you do is you make a slit on the short part of the string with the scissors, and you bend it in and put it into the long side. So each short one goes into the long one, all the way around, and you make the faces that way.
Okay.
So here are the 4 faces. And then you take some Scotch tape and you put a whole bunch down, is what I do. Reasonable size, like this. And then you put 2 pieces of Scotch tape on each face, on each edge, I'm sorry. 2 on each edge to hold it. And you make the angle as you do it approximately correct. So, you don't do it flat. You make the angle the way you want it. And then you just put them all together. And so here is the regular. And of course, you can only, unless you cut the straws down in some way, each edge is the same length. So this makes regular polyhedra. Not always. You can make, as long as each edge is the same length, it makes the regular ones and it makes others too. So you could make a square-based pyramid as well. I haven't made one of those, but because every edge is the same with equilateral triangle faces, 4 of them that would be instead of a triangle base, and all the edges would still be the same length. Anyway, that's this one, and this is the cube.
Yeah, okay.
I made 6 squares, so 4 straws per base, 6 squares, and put them together. So you have two straws in each edge. Okay, is that clear?
Yeah, I got it.
Okay, and then I also made. So this is the other one, and we'll talk about the symmetry next time. This is an octahedron. It's called an octahedron because it has 8 triangular faces. So it's basically 2, okay, so you can see. And we're going to look at the symmetry of these guys. And then, Walter, you had asked about other 3D properties improving things, and I can put there's some interesting facts about these guys, and I can do it. Let me ask you something else. Are you folks familiar with the golden section? Or the golden mean? Or is that?
1.618.
Oh,
Yes. Yes.
I've heard of it.
Yeah.
I haven't done anything.
It's quite significant and interesting. So, okay. So I have a nice activity with that I will consider doing. Okay. It was considered next to pi in geometry the most important number. All right, so I did that. Now we did that. All right, so you'll need to make these things to look at the symmetry for Friday. Now I want to start.
What?
I made a sheet called Matrix Basics. And it's in eCollege. And it's in the class files. So you should open that, and I will open it too.
Yeah, what's this? Yeah, I'm just gonna look off you because that's happening.
So let me think for a minute. Yeah, okay, I'll share my screen now and make sure I share the right one. Yeah, that's the right one. So share entire screen. All right. So you should have a sheet that looks like this.
Oh.
You got it?
Yes.
All right. So what I want you to do now yeah, I'm going to give you some time to, and I assume you've had some experience with matrices or not?
Yes.
Yes, but it's been a while,
Not too good.
right? Okay, so this is a review, and then we're gonna use this with our transformations. So what I want you to do is start. Don't do a lot of these. Just do like one of each type. And you can either print it out and do it by hand, if you can do that, or you can do it right on here, whatever you want. But I want you to go through. I'm going to give you some time to go through this and do, like here's a lot of exercises. Just do one or two to make sure that you understand what's here. All right? So I'm going to be quiet for a while, and I'll check in again in 10 minutes and give you guys time to work on this. Okay? After 10 o'clock. Okay, I just want to check in. Any
I-
problems so far?
Um, I don't think so.
Yeah, not yet.
All right, where are you?
We're in the we're multiplying matrices.
Okay. So like which letter? K, J, K, something?
L
L. Okay.
or M, and we're on N.
Okay. Good. In terms of typing, do you guys have you downloaded MathType or can you use it?
I tried to. I couldn't figure out how to get like the actual thing to download.
Okay. If you double click on one of these things, does it, can you copy and paste? Does that work?
I don't think it worked for us, but we can add
Okay.
matrices in ourselves.
Yeah.
Oh, okay. Yeah, it would be good to, it would be good. So, okay. So, let me, well, okay. So let me see if later on I can help you today, get it. So it would be good if you had it. All right. So let's see. So you're on M and N. All right. So, yeah. So let's do another 5 minutes and then we'll stop because that's good. So it's 9:24 now. So we'll go till 9:29 or 9:30, and then we'll do other things. All right, good. I'll mute. I realized I can mute my microphone, and Walter did too. It's in the right side of the screen, the Blue Jean screen. So I'll mute myself. Okay, can you hear me?
Yes.
Okay.
So it should be
Uh,
6 by 6, right?
all
Or
right.
no, 3.
No, yeah, it's supposed to be a 3 by 3.
Okay, cool. I'll do it.
So just finish up the last thing you're doing, and then the rest is for homework. And we'll go on. Walter, you with me too?
Yeah.
Okay. The next thing that I want to do is to one of the homework, part of the homework for Friday is going to have, let's say this right, is to make corrections on test 2. I noticed that there were some difficulties. And that's more of a job for some than others. But I want to go over. So I'm going to get up. Here's Logan's, and I just want to make sure that on this PDF, Logan, and Ryan, the same for you. Since you sent a PDF, I have these Post-its, and I want to make sure you can open them.
Yeah.
So, right, you can open them. So when you hover over it, it says, or if you click on it, then it opens it to the right, and you can see what I said. So I want to, and then you can close it by clicking on this upper right corner here that closes it. So I put your score in the first one, but then I put comments, and I want you to read those comments and make corrections. You can download, you can make corrections on however you want it. You can do it on a separate document. You can print it out again and make the corrections there. There was, in Walter's case, Walter turned in a doc. And so, Walter, for you, I made these comments here. And I want you to respond to those. But I also want to, the first question was a problem. So I want to go over, this is the theorem sheet. And this is in the reference, right? I uploaded this, I'm pretty sure. I'll check. So it has the assumptions and it has the preservation properties and stuff. But this part here, and maybe I'll extend it to 3 a little bit because we didn't do much with 3. 1, 2, and 3 reflections. And 1 reflection is no problem, but there were some theorems here that you all forgot. Isometry is equivalent to 2 reflections. Remember that we did this? If you have successive reflections in parallel lines, then that's equivalent to a translation. You can read that. Yes. By a vector perpendicular to the lines in the direction A to B with length twice. And this was the one that people forgot. Successive reflections in intersecting lines A and B, if they intersect at P, is equivalent to a rotation through twice the angle from A to B. And so, if we go back to here, and it says a twofold figure has 2 perpendicular lines of symmetry. So what other symmetry must it have?
Twofold rotational.
Yes, because, Walter?
Because you can map, by doing the composition of the reflections across both perpendicular lines, you can map any point by a half turn.
Right, it's equivalent to a rotation through twice the angle, and since the angle is 90, it's equivalent to 180-degree rotation. So it has to have twofold rotational symmetry. Is that clear, guys?
Yeah.
Okay. So that was, there were a lot of problems on that. But All right, so I'm going to give you some time again, right now, to look through this and just 5 minutes to start, and then we'll go on to something else. So just 5 minutes. But I want you to look through, and I want you to read at least some of the comments. And if you have questions now, then ask them. Okay? So it's 35. I said 9, but it's obviously your hours are different. But it's so like on CNN, they say 35 past the hour. That's what it is. Okay? So 5 minutes. I want you to open your test document that I sent to you, and look at the comments that I made, and see if you have any questions. So 5 minutes for that. Okay. Can you all get the document? Yes?
Yes. Mm-hmm.
Yes.
Oh, please look at it. So I should see some keyboard work. Okay, 30 seconds to finish up. Okay. All right, I want to show you a couple more things. So in the homework, doc sharing homework, I made these files called, for example, Transforming Graphs Plus. And so the plus at the end means I did more. And so you can see a little bit more about what I had in mind. So I put the solutions to these problems in red. And this is what I'm looking for. So these are the solutions here. And I put more steps in terms of the steps to find the equation of a transformed graph, because I wasn't always getting, so on the last two, I didn't seem to quite have the idea. So especially in number one, specify the equation of the original graph and also listing its essential characteristics will be helpful for step two. And step two was the one that I wasn't getting. Describe the sequence of transformations that maps, actually make a description in words. Sequence of transformations that map the original graph onto the transformed graph. And this critical step will often require a graph and an explanation. That's the important part. The order of the sequence matters, so specify it clearly. It will generally be easier to do the translation last. And so on some of these later ones, I put a solution in so you can see what I have in mind. So here's the solution for number 4. So I needed to see this kind of thing. So you can read it later, but this is what I'm looking for. And I put a solution in for 5 also. So 4 and 5. So I'm going to reassign 6 and 7 slowly, and I want you to do it this way. So I see what's going on. So I hope that's helpful. Close that. And then similarly for the history and utility of complex numbers, because some of you didn't seem to understand what was going on with the missing steps. So in red, it says missing steps. And you can look at this and see that was the algebra that I talked about, but talking is not, my talking doesn't do it. So just look at it, look through it. And then we're going to get into, so this was all the algebra stuff. We talked some about this last time. And then, so the missing steps that some of you had questions on are here. So I want you to look through that. And then 6 and 7 we haven't done yet. And 6, the red on 6 is what I want you to do. So that's clear in the assignment. All right, so I'll close that. And I can close this. And I can close this. All right, so the new thing that I wanted to talk about a little bit today was inversion or reflection in a circle in GeoGebra. And I asked you to just look at it. So I'll open GeoGebra, and then we'll talk a little bit more about it. Get geometry, and make it big. And just make a circle. And I don't know if you realize, but this is the move graphics view, and you can move things around that way. Move this point over here out of the way. And So I can make a point somewhere. Do it right. Point there. And under the reflection or the transformation tool, which is here, there's reflect about a circle. And it says to select the object in the circle. So let's show the label on this. So this is point C. And you can reflect it. So I select C, and I select the circle, and there's C prime. And I asked you to look at that and think about what you notice. And of course, the key thing about GeoGebra is moving stuff and seeing what happens. So what did you notice?
That even though it's reflected, it doesn't move the same distance from the inside of the circle as C does.
Okay.
Like if you move it like way farther out, it doesn't move the same way.
Mm-hmm. It doesn't move as far. So if I move, if I move C quite a distance, C prime doesn't move very far. Mm-hmm. Okay. Good. Somebody else. So what else?
Oh, the 3 points are collinear, and the length.
Okay, stop. That's good. So Walter said that the 3 points are collinear, and the 3 points are this point, which is called what?
Image.
C.
Pre-image?
C is called the
Pre-image?
pre-image, and C prime is the
Image.
and this point is the
Center?
center. Yeah. So those 3 points are collinear. Do you agree?
Yes. Yeah.
Okay. Okay. Logan, can you tell me anything else?
If you drag C into the circle, maybe, it'll do the opposite. Like the closer you approach the center,
What?
the more it'll move away.
Mm-hmm. Okay. Okay. Walter, you were going to say something else, and I stopped you. What were you going to say?
Length CA times length C prime A is the square of the radius of the circle.
Okay. Did you know that, or was that something that you measured and came up with?
I measured it.
You measured it. Okay. Good. So let's do that. So let's see. So the measurement, yeah, that's here, right? Distance or length. Okay. Select 2 points. Okay, so what I believe that Walter did was, let's see, select this point and this point. There it is. And so CA is 1 point. Let's move this. Just move, yeah. Oh, I see it. It keeps it close. Okay, so there's CA. And then we want C prime A. Which is here. That's 7.4. I have to go here. Okay, so that's... And then the radius, well, okay, here's a point on the circle, point B. I want to show the label. Okay, so B is on the circle, and we want that distance too. So and so, Walter, can we do calculations on this? I don't know. In GeoGebra, do we have to use like a calculator for that? How did you do it?
I just eyeballed it, and it was pretty close.
Okay, so if you multiply 7.4, actually, by moving this, we can let's see, oh, I have to move C. Let's try to get a whole number here. Yeah, it's pretty close to 2. Okay. So 2 times 8.5 is 16, 17 roughly. And yeah, and 4.1 squared is going to be pretty.
0.01.
Yeah.
So
okay.
It's
So the interesting thing is that product seems to be constant, right? So as you move it, and why does it have to be the radius squared? If it is, assuming it's constant, why must it be the radius squared?
by the definition of a reflection about a circle.
Well, yeah, but suppose, you know, we didn't know that. Could this constant be something else? CA times C prime A. Could it be anything other, if assuming it's constant, could it be anything other than R squared?
I'm not sure how you can figure that out though.
Okay. Ryan Logan, you have any idea?
No.
All right, suppose we put the point on the circle.
Oh, that's what you're going for? Okay, yeah.
That's what I'm going for, yeah. If the point is on the circle, then it seems to reflect into itself, which is kind of what we'd want for, you know, a point on a line reflects into itself if the point is on the reflection line. So it would make sense that if the point was on the circle, it would reflect into itself. And now the product has to be R squared. So yes, that is the definition of inversion in a circle. Okay? That the product of, that the points are collinear and the product of their distances from the center is the same as the square of the radius. Okay, clear on that?
Yeah.
Okay. Now I made two sketches, and I'm going to open them. And I've learned that if you make a new window, I can keep the old one. And is this a recent one? Yes. So I made two. One is inversion pre-image inside, and the other is inversion pre-image outside. And I've put those both in the homework in Doc Sharon under the homework for the 17th. I also made folders or categories for the 20th, but those aren't used yet. So make sure you look at the 17th. So I'm going to open both of them, which I'm not sure which one I want to do first, but okay, so this is outside. Yes. And this is inside. All right. And let's do outside first. So, how do I do this? Oh, yeah. No. Oh, I see. I didn't make a new window. That was my problem. Okay, this is inside, and now I want to make a new window to do this. And now that was inside, right? Yeah. I want to do, which one was that? Inside, yes. So I want to get outside. Here. All right. Okay. So so this is the outside one, and I made it small just because I needed it for a diagram. So I'm going to blow things up a little bit. This is, so point P is outside the circle. And what this is a construction. You see? Somehow this is getting us the construction of the image point P prime. But it only works when it's outside. See, when it's inside, nothing happens. But if P is outside the circle, then it does work. And one of the things that I'm going to want you to do is figure out how this construction is working. What's being done? What are the steps? All right, so think about that for a minute. We'll come back to it. And then similarly, here is the inside. Here, the point A is on the inside of the circle. And this is a construction of the point A prime on the outside. And if we move A around, it gives us the image point under reflection in a circle. And somehow this is doing it in some weird way. Okay. In that case, you can't there. You can see it. Of course, it doesn't work. This one doesn't work when it's outside. So this one only works on the inside. So let's go back to the outside one, which is the one I started with, a little easier. And so let's, we got about 3 minutes left. Let's see if we can figure it out. So think about this. How is this construction being done? So just think. 1 minute think time. Okay, I think some people have ideas. So who's ready to say something? And try to describe it really clearly.
So P is an arbitrary point, and you then construct the circle with radius PO.
Okay. Okay. Stop. That's a good start. Radius PO. Can somebody else go on? Sorry, Walter, but I want to give everybody a chance. Ryan, Logan?
So Walter said the circle with PO, right?
Yes. Construct a circle with radius PO, yes.
So we're just describing how to make this image?
Yes. How to get P prime.
Okay.
So we've made a circle. We've made this first dashed circle here with radius PO. What's next?
Would you have to then make circle
What was the point of making that?
Oh, so then you could find the center of circle O? Or
We know the circle, that's the given circle, circle O. Logan?
no,
You find the intersection between P and O, which will be A.
Okay, so the purpose of making that circle was to find the intersection point, which was point A. Yes. Okay, so now we have point A. Here it is.
You draw a circle around A with radius AO.
Okay, and good. Ryan, can you finish it? So we've drawn this circle now.
and then you find the intersection of circle A.
Yeah,
Or
and
circle and the radius of P,
and
or the intersection of OP.
yes, good. Yes, you find out where that circle intersects OP, and that is P prime. Good. Okay. So that's what I'm looking for. And exactly. And I'm going to want you to write that down. And then the other one, so we're out of time now, but you have to figure out this one in a similar way. Okay? So I want you to figure out what's going on here. Good. All right. We're out of time. Thank you very much. Have a good week. And take care. And if you have any questions, I'm here.
Definitely. Okay. Thanks.
All right, take care.
Bye. Thank you.
Sure. Bye.